You need to know it. I don't believe that it appears on the PERT formula sheet, so you want to memorize it. As I've said, there's two really good ways to memorize it. There's the really annoying song to the tune of Pop Goes the Weasel, and if you sing the formula, just say exactly what you see. It's perfect with Pop Goes the Weasel. And I will sing it for you. Okay? X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. See, it fits perfectly. Okay? The other way I know to remember it is the story of the boy. He's a negative boy. So we have a negative boy who couldn't decide whether or not, that's the plus or minus, to go to the radical party. Now you have to know that this is a radical, but he was square. So he missed out on 4 awesome chicks. No, he was square. Yeah. You guys know what that means, right? If somebody's square? That's a really old phrasing. Like back in the 60s, if you were square, it meant you were a nerd. Okay. So he missed out on 4 awesome chicks. You guys know what awesome means back in the 80s? If something was awesome, it meant it was good. And it was all over by 2 a.m. Okay, so negative boy couldn't decide whether or not to go to the radical party, but he was square. So he missed out on 4 awesome chicks, and it was all over by 2 a.m. Okay. The numbers that we put in are these numbers, the A, the B, and the C. This has to happen. It has to be equal to 0. If it's not equal to 0, you can't use A, B, and C. You have to make it equal to 0 first. If there are no numbers there, if it's just x squared or if it's just x, that's a 1. Okay, so no coefficient equals 1. If there's no x or no c, they equal 0. So like if it was say x squared plus 5 or something, then the b would be 0. Or if it was x squared plus 3x and there's no c, then the c would be 0. If there's no x squared, it's not a quadratic formula, don't worry about it. Okay. We're going to start with a very basic one. This one is factorable, but we're going to just do quadratic formula. Okay. There's no number here. That's A. This is B. This is C. If there's no number there, it's a 1. Okay. My recommendation, until you have this memorized, I would write it down every time. That'll help you to remember it more. Okay, both of the B's are going to be replaced by 5. Both of the A's are going to be replaced by 1. And the C is going to be replaced by 6. Just double check myself. Okay, so B is 5, so I put the 5 there. B squared, so 5 squared, minus 4 times A, which is 1, and C, which is 6, divided by 2 times A, which is 1. Okay. We have to work everything inside the radical first. So everything under here has to be done first. Okay, so 5 squared is 25. 4 times 1 is 4, times 6 is 24, so minus 24. I tend to also at the same time go ahead and multiply that because it's separate, so I can do that without messing anything up. So 2 times 1 is 2. We're still going to be working under the radical. Okay, I'm going to come up here so I have room. 25 minus 24 is 1, divided by 2. Next, I need to deal with this plus or minus situation. Okay, I have to do both. The plus, oh, I'm lying, we're not dealing with that next. We have to do the square root of 1 next. I'm getting ahead of myself. Square root of 1 is 1. That one's easy. Okay, now we deal with the plus or minus situation. Okay, we have to do both. So I have to do negative 5 plus 1 divided by 2, and I have to do negative 5 minus 1 divided by 2. Okay, they both have to happen. Negative 5 plus 1 is negative 4, and then negative 5 minus 1 is negative 6. And then last, you divide by the denominator, divide by 2. So negative 4 divided by 2 is negative 2, and negative 6 divided by 2 is negative 3. So you're going to have 2 answers. The only time you won't have 2 answers is if there's a 0 under the radical. If there's a 0 under the radical, once you solve that all out, like let's say I ended up with B is 6 and C is 9, that would give me 36 minus 36. So I'd get a 0. And the square root of 0 is 0. So that's the only time you'll end up with one answer. This one will come out evenly. So here's another example. This time we have an A, B is negative, and C is also negative. So again, until you have it memorized, I recommend writing it down every time. Okay. Now, negative B, there's already a negative there, and then B is negative, so you're going to have a double negative in that situation. Plus or minus B squared. Be sure to put the negative inside the parentheses because you're squaring it, which is going to make it positive. Just as a refresher, there's a difference between these two things. If the negative's hanging out front, your answer is negative. If the negative's inside the parentheses, your answer is positive. So that's why that's important here. Be sure you square your negative, okay? Minus 4 times A times C. Divided by 2 times A. Okay, I'm going to be working underneath the radical and doing this multiplication. Also, my double negative is a positive. He's happy. So I get 6 plus or minus the square root of 36 plus, because I have 2 negatives, here I'm getting a plus. So 4 times 3 is 12, times 4 is 48, divided by 6. $36 and 48 is 84. think. Yeah, it's 84, okay. Divided by 6. So we did this part next. Okay, the square root of 84. Not a perfect square. Depending on, actually I'm going to bring that over here. Depending on what type of problem you're trying to do, depends on what we do next. Okay? If you want a decimal answer, you'll do one thing. And if you want an exact answer, you'll do another. The decimal answer is going to be rounded because the square root of 84, not being a perfect square, is going to give us, it's an irrational number. It's going to give us a non-repeating, non-ending decimal. So there's no way to do anything with that unless we actually round it. So we'll do that one first. And that one requires the use of the calculator. Oh no, I'm doing the decimal first, the calculator first. If I do that first, I plug in 84, take the square root of it, and I'm going to get 9.16515, blah, 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 forever and ever, right? So I'm going to take it out to 2 decimal places. That's usually safest. Take it out to at least 2 unless you're told specifically which decimal place to take it out to. So I'm going to take it out to 2, and I get 9.17 divided by 6. Okay. From here, I have to do the 6 plus 9.17 and divide it by 6. And the 6 minus 9.17, divide that by 6. 6 plus 9.17 is going to be 15.17 divided by 6. And then the 6 minus is going to be negative 3.17 divided by 6. And so at the end, I'm going to be rounding again because when I divide this, I'm going to get 2.5283 repeating. So I'm going to go ahead and do 2 decimal places. So I'm going to do 2.53 and then 0.317, oops, sorry, 3.17 divided by 6. I'm going to get a negative 0.53. So that's the decimal version. I'm going to need more space for this one. If I want an exact answer, I need to leave the radical in it. But I need to try to simplify the radical, which we did in the first part. Remember doing that? Make a factor tree. We have a pair of 2's that can come out. And that 21, the 3 and the 7 have to stay inside. At this point, you may or may not be complete. You may or may not be finished. What you have to do at this point is look at these 3 numbers and see if all 3 of them can be divided by the same number so that you can reduce the fraction. Okay. 6, 2, and 6 all divide by 2. So this can be reduced. I'm going to divide all of them by 2. 2 divided by 2 is 1, and you can leave that out. Oops, not 6, sorry. And this is your final answer. Okay. You can also write this separately, which would give you 1 plus or minus the square root of 21 over 3. But that's not necessary. Most of the time, this is perfectly fine. If you see something like this in a multiple choice, though, I want you to be able to kind of recognize what happened. I won't require you to do that in a class, though. Let's do one of those. Let's say I get something like that. Okay. Okay. Negative b squared minus 4 times a times c divided by 2 times a. So I have my negative 2. 2 squared is 4. 4 times 30 is 120. So that 4, that 30. And 2 times 6 is 12. And then when I subtract, I'm going to get 116 negative over 12. Depending on the situation, okay? If no imaginary numbers allowed, then your answer is no solutions. But if you're allowed to use imaginary numbers, then we have to go further. Okay? So I'm going to take that 116 and I'm going to factor it and see what I get. Okay, 2 times, I can pull out a 2. And I pull out an I. The I is taking the square root of the negative. And I leave the 29 behind, and I have a 12. And 2 and 2 and 12 will all divide by 2. So I get negative 1 plus or minus I times the square root of 29 over 6. Anytime you have a negative under the square root and you're allowed to use an imaginary number, you have to pull out the I. And I'll show. Let's say, just throw out a bunch of negatives in there. Let's say I have something like that, negative square root of 5, or square root of negative 5. I can't do anything with the 5 part, but because there's a negative there, I have to simplify it. I bring out the I. Okay? If I have a perfect square, but it's negative, I take the square root of the number and I put an I behind it. If I have a number that has a perfect square in it, like 12, 12 is 4 times 3, I pull out the perfect square part, I pull out the negative part, and then I leave whatever's left behind. Okay? So if there's a negative, you absolutely need to pull out the I, if I is an option. So like I said, it'll depend on where you are in math, like especially on the PERT. If you're in the early sections, the developmental math parts, it's not going to be allowed. But then when you get into the intermediate part, the end part, it is allowed. So if it'll either be in the answer choices or it won't. And if it's not in the answer choices, the answer to this right here would be no solution. To be set equal to 0. Well, what if I have something like this? Don't use 10 as C. C is not 10. Yeah, I have to subtract 10 from both sides or move it over first. And then I say equal to 0. So it has to be equal to 0 before you can use A, B, and C. Okay. And if I have something like that.
Minus 19.
I can do this two ways. I can then put in a 0x, and that makes B equal to 0, and solve my quadratic formula. Okay. If I don't have an x term, though, I have other options. I can use the square root property. I can divide both sides by 3. Here, let's make this a number that actually divides by 3. That'll be nicer, yeah? Okay. I get x squared is equal to 6. And then I can take the square root of each side. If you do this, you need to remember the plus and minus. Okay, because it's both. So if you have no b term, you can either plug a 0 in for b and use the quadratic formula, or if you remember, you can use the square root property and solve it this way.
That'd be the answer right there.
This would be the answer. No matter which way I do it, I'm going to get the same answer. Okay. Do you want me to work it out with the quadratic formula? Do you guys want to see it? Anybody want to see it that way, or are you guys okay with this way? If it came out as a perfect square, let's say I did 3x squared equals 75. And then I'm going to divide by 3. So I'm going to get x squared equals 25. Perfect square. I'll take the square root of both sides. I still have to do the plus and minus. But it'll just be a real number, or a whole number that time. This is also a real number, it's just not a whole number.